Welcome to the MSQL Tips webcast, keeping the peace with your sysadmins while providing SQL Server High Availability, sponsored by SIOS. I'm Greg Robidoux, co-founder of MSQL Tips and the host for today's webcast. Our speaker today is Dave Bermingham, who is a Microsoft Clustering Datacenter MVP, and today he will discuss how to get the best HA protection for SQL Server in a VMware environment when you need to work with several different teams. During the webcast, we encourage you to ask questions. To ask a question, enter your question in the question area in your presentation controls, and we'll answer as many questions as possible during today's webcast. In addition to today's event, we invite you to check out all of the free resources on msqltips.com. If you're not already a member of the community, we invite you to join. You can go to www.msqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Greg. So before we start, I'm just going to ask this question, a poll question here. Have you ever had discussions with your VM admins regarding the limitations of VMware HA or any other hypervisor-based clustering solution for SQL Server?
All right, that poll is launched, so everybody can take a couple seconds, just answer that question, and then we'll cover the results. All right, get a good amount of the audience already voted. I'll just give another 10, 15 seconds, and then I'll share the results. A couple more votes coming in. All right, I'm going to close that, and I will share the results. So we have 62% said no, and 38% said yes.
Okay, great. Well, it's good to know. I mean, we're going to be talking about that today, about some of those limitations and why you should be talking with your VM admins about that in particular. So, have you ever gotten the call at 3 a.m. that your big production mission-critical SQL Server is down? You know, the one that just got virtualized against your recommendations and without any input from the DBA team? One where they said they had high availability taken care of without asking you the actual requirements of the application stack. So the problem here is that the HA solution that the infrastructure and VMware teams used worked best for them, but they left out looking at the requirements of the application and talking with the DBA team. So if the wrong HA solution is implemented for databases, the business can be impacted, and sometimes quite severely, by the database being offline for much longer than allowed by the business. It makes it tough to fulfill your obligations as a DBA, which includes ensuring the database availability for the business. So as a DBA, what can you do? Well, the first step is to have a strong conceptual understanding of the infrastructure's layers above and below the database. So starting at the bottom of the infrastructure stack where we have our shared storage, then you have the network and the fiber layers connected to the SAN to your physical servers. And then if you have the virtualization in your environment, you also have a hypervisor sitting on top of the physical server. Then you have the virtual machine configuration and the operating system that runs inside it as well. And then finally, you get the SQL Server instance and the critical databases, and we all have a good idea which works best for the databases. But outside of that, you also have your applications that fetch and present data from the databases to the end users. If it's down, where in the stack is it down, and how complex is it to set up and manage in the first place? So every one of these layers has high availability methods that work best with the least complexity, and your administrator for each of these layers have their preferred methods that might already be in play for other application stacks. The challenge here is that what works best for one IT solo might not work best for another. Sometimes it can actually result in lower availability for the database. And sometimes it can result in some very complex architectural designs to keep the availability where you need it to be. Now, these discussions can be quite entertaining, to say the least. Sometimes these discussions can get animated as the sysadmin and DBA argue about whether to cluster or not, and neither are willing to back down on their opinion. So what can you do? What do you do? So first thing I recommend is everyone calm down and just take a look at the business. So I say drop the technology talk up front and focus on the business requirements. You got to get the business people and members of all the infrastructure layers in the same room together and talk through the actual business requirements around the database and the application stack themselves. First, discuss the needs of the application stack. The database layer is the base of the application stack, and if a database instance is down, multiple applications can be impacted. So what sort of outages can we expect? Define some of the failure scenarios that the application stack might encounter, such as physical server failures, blue screens, networking port goes down, or other significant events. And then define the outage windows that the business can actually withstand. Sometimes it varies based on the time of day or time of week or period of the year. Sometimes it can be as simple as no greater than 5-minute window interruption during the business day from 8 to 6 p.m. And you might have more extended flexibility if it's after hours or on the weekends. But if it's a web server that's up and servicing your clients 24 hours a day, that could be a different story. So keep in mind the fact that if a database server is critical, it's something that multiple business critical applications depend on. These applications can be how your business makes its revenue. So every level of protection must be taken for them because it's the business that you're protecting. As a result, look at it from a business perspective and start to define some of the SLAs or service level agreements. If you don't have these defined in your organization, take the initiative and work to get them established. What you'll find after you get them nailed down is that usually your business has far different expectations on availability than what is currently system architected to provide. It can be pretty eye-opening. So you have to define the big three things. The first is the recovery time objective, also known as the RTO. This is how long it takes the application stack from your SQL Server up to accepting connections if the failure were to occur. The second is the recovery point objective, also known as the RPO. That's the amount of data loss that is acceptable or not acceptable if the system were to fail. The mean time to recovery is the average time that a device takes to recover from a given failure. It could be 0, such as a single drive failure in a RAID array or a networking path in a multi-path configuration. However, it can take time to install a new drive and fully recover the array, which takes time, or the switch, the networking cable port needs to be working, could take time to replace. The system is not necessarily down, but it could be running in a degraded state. So after we define the scenarios, define the outage windows, and there could be different for different types of apps. You have to define your SLAs and your recovery time objectives, your recovery point objectives, and the mean time to recovery. So remember, not all the systems are to be managed the same way. You have to differentiate between planned and unplanned outages. This is one of the biggest sticking points that I see between VM admins and DBAs. What I mean here is that some of the VM level HA technologies can protect against hardware failures. However, they don't help with the operating system if you need to do a Windows patch. So determine if the organization has maintenance windows for that application stack for routine maintenance. If not, you must plan accordingly. Production can be quite different from pre-production systems. Some production systems might not be as critical as others, such as a database server underneath the corporate antivirus deployment. Just remember to keep the complexity as low as possible for the application stack, because the more complex a given system, the harder it is to triage in the event of an emergency. Put all these together into an application classification matrix to make it very easy to see what is needed. So the classification matrix helps visualize the impact of the application stack on the business. Some of the classifications can be the items that we talked about, and feel free to modify these classifications according to your business requirements. From there, now you can define the availability requirements for each component of the application stack, such as web servers, load balancers, application servers, and your focus, the database layer. So what options does the infrastructure have for HA features anyways? First, the virtualization high availability is the detection of a component that fails. Either the physical host that runs the VM or the VM itself blue screens, and the hypervisor can detect this. Well, what does it do? If the host were to fail in this example, the watchdog agents in the virtualization environment detect the failure. The VMs are down just like you pull the power cord out of a physical server. The hypervisor watchdog knows the VMs are running on the failed host and will quickly analyze the remaining host and look at the load levels. If we have a large VM footprint on one host, we can also help load balance. It restarts the VMs that were on a failed host on the other host. Windows still has to boot though, so SQL Server still has to go through a crash recovery before it starts listening for connections. But you don't get that super long BIOS post process because of the benefits of the virtual layer. So the VMs are back up and SQL Server comes back up and begins to listen for connections on the average of 2 to 3 minutes. And I like to say that VM level HA gets the VMs back up in under 5 minutes or less in case you have something that causes delays in Windows to come up, like a goofy group policy in Active Directory or lots of VLFs in the SQL Server database that cause an extended window for startup. So as I said before, VM level high availability is simply resiliency against host level failures. Virtualization HA is minimizing the risk and reducing the downtime when an infrastructure component fails. It does not go into the OS to protect against outages for patches or handle anything in an application-aware manner. The operating system must restart between patches or other tasks, and there's no protection there. The application must start up on its own, so SQL Server has to make it through the crash recovery just like a normal system startup. So if you have any number of reasons for SQL Server to take forever to start up, then such as the huge transactions that were in flight when the server went down and need to be rolled back, SQL Server can still take a while to start up and begin listening for connections. In most cases, I claim the virtualization HA is complementary to SQL Server HA, but not usually a replacement. But some places have SLAs that are lenient enough that they don't need more complex HA strategies. We do have one HA technology that is quite advanced that can help to reduce the outage windows of a system failure. It's specific to VMware and most importantly vSphere 6.0, which includes fault tolerance. We're now able to protect a VM against hardware failure by having a hot copy of that VM up and running on another host. If the host fails, the second host will take over that host with no interruption to the client connection. But there is some VMware size limitations there. You see listed of 4 CPUs and 64 gigs of RAM. The biggest challenge is the discrepancy in understanding between the silos. VM level HA does not protect you from outages during a hardware failure. It helps make it more resilient, but that's not 100% coverage. Now, VM admins love to use this technology over more complex HA strategy, and in a lot of scenarios it works well, but VM level HA does not help you for planned maintenance outages, such as Windows or SQL Server patches. I find that this is one of the most common points of contention between DBAs and VM admins. Let's say I have to apply a Windows service pack. That can take an hour or two, and during that time, the SQL service itself could be unavailable. VM level HA will not protect you from this outage as the VM is still up and the hardware is still working as designed. That service is now usually down for an extended period of time, and any application that is connected is down as well. Plus, even if SQL Server is up, the VM admin usually has taken a snapshot of that VM prior to the update, and if that causes a problem, they could revert the state of the VM so that they can recover from the problem easily. However, if SQL Server is up and those disks are not marked as independent from snapshots, you have just all your database's changes are disappeared if you have to restore that snapshot. So the biggest takeaway is that VM level HA does not protect you from any bad architectural decisions that are in place in the environment. You could have a SAN failure that knocks out all the data, and you could have VM admins that do not have the experience in troubleshooting a networking path down scenario. So mixed resource clusters not set up with advanced thought in the load balancing and resource reservations can make VMs not able to be fired up if a host fails. It takes planning to understand the implications of any virtualized data center design and your HA strategy for your different tiers of your systems and applications. So one of the most common scenarios I see is with a production critical application, specifically SQL Server, with a very important 24/7 web application on it that happens to be public facing. This could be something like a database underneath a payments portal system for your clients, or ETL server, or reporting warehouse, or a database underneath an around-the-clock manufacturing facility. They have requirements of no data loss for any sort of outage, both unplanned and planned. Application is set to retry connections to the database for up to 30 seconds, so your windows for any system interruption is only 30 seconds. And beyond that, the application will start to throw errors and the users will notice. Plus, your client contracts state that you have a 5 nines availability guarantee per year, which translates to no more than 5 minutes, just a little bit over 5 minutes per year, and that's per year. So if VM level HA is your only strategy in use, and it will take just 2 outages to most likely exceed this limit. But that's not even accounting for the routine maintenance, which is not factored into this number. You have no maintenance windows at all for Windows patches or SQL Server updates. So VM level HA will not protect you from system interruptions in this scenario. You have to start with some sort of advanced SQL Server high availability now to complement the resiliency introduced with VM level HA. So what are our options? So SQL Server has a lot of great features for HA, but all of them have their nuances and complexities. One option is to not have any SQL Server level HA, but in that scenario, that doesn't work. You have traditional shared storage clustering with Windows Server Failover clusters. It's complex, and when it's in a VM, you have to deal with the challenges of the shared disk configuration. We'll get into that a little bit later as well. Then you have the deprecated database level mirroring. It's still available in 2016, but it should be going away soon. Then, of course, availability groups, which is replacing the database mirroring, is available in 2012 R2 with the Enterprise Edition of SQL Server, and it's good, but it can be cost prohibitive with the requirement for Enterprise Edition SQL Server. And other folks are still using replication or log shipping for HA, but each of those have their advantages and disadvantages as well. And sometimes the application itself won't even handle that sort of protection very well. So what do we do? In our scenario, no HA is not an option. Mirroring won't work because our app won't support it. They won't support the dual node connection string, and replication is too complex for the application. And log shipping is not the right choice here because of the potential for data loss. Let's look at the VM level view of these strategies. So our SQL Server VM, protected by VM level HA, is running on your normal virtualized environment. The virtual disks are spread out on different shared LUNs and are disk comprised of OS, multiple disks for data, logs, and indexes, and are centrally located so that they are available from all of the hosts in the host level cluster. So if a host fails, the VM itself is remapped onto another host, and the VM is powered back on. And that's your outage window as the VM starts back up. So we talked about that earlier. It's about 2 to 3 minutes, typically, or longer in some cases if SQL Server is going to have to roll back some transactions or take longer to start up. Windows Server failover clusters inside of VMs is a bit different, and you have multiple VMs with independent disk for the operating system, but the SQL Server volumes are directly passed through the hypervisor to each of the VMs in the cluster. So Windows inside the VM manages who owns the storage and which others are passively connected and waiting for the failover. These pass-through LUNs are a major sticking point for the VM and SAN admins. First, SAN admin now has to manage more LUNs than they want to, mostly in part because the virtualization allows them to cut back on the number of LUNs. It makes it easier to manage. Now, managing the shared volumes task takes more work from the VM admin because now they have to handle things like the disk presentation itself, VM level snapshots, VM level backups, and VM mobility. All those features behave differently using the raw device mapping. So the Windows Server failover clustering portion of the setup makes life a lot better for the DBA. We get the ability to not have to change the connection string in the application if the cluster fails over. We can fail over to do things like system maintenance with just a small interruption in service. But the conflict is quite challenging. So who's in charge of the availability for the environment? In essence, everyone's in charge. The SAN admin must deal with the shared disk for things like the cluster quorum, the data and log, and these things have to be available on that single point of failure called the SAN in order for the environment to stay up. The VM admin must now have to deal with VM mobility and no snapshots, so their backup strategy is going to change most likely. The shared disk configuration and limiting the VM mobility on older versions of the hypervisors in some configurations is a non-starter. The Windows admin handles all the Windows Server failover clustering stuff, which is no small feat in itself. And sometimes the DBA will handle this, but usually the DBA doesn't have access to Active Directory to help with some of the initial install issues involved with the AD permissions and group policy conflicts. So then there's you, the DBA, who's the last one in this chain to have to work through all these layers to keep the databases up, and it can be tough sometimes. So now it crashes. What do you do to get the environment back up? Where is the visibility for the DBA to see the other layers if the issue is outside of SQL Server? So availability groups, things get a little bit better because of the removal of the shared storage component. But you get a lot of other gotchas. As mentioned with other scenarios, who manages each layer and does the DBA have the visibility into it? You've got some of the same challenges as well, plus the fact that the whole instance is not protected. Availability groups are not perfect, with things like logins and jobs not being replicated between the availability groups nodes. You've got worker thread count limits, you've got database limits, and other things like that which can get in the way of the total protection. You also have some features that are just plain not supported, like distributed transactions, replication, SSIS catalog. If you want any of that, then you're out of luck with AGs. The biggest factor here, once again, is that it requires the Enterprise Edition, and that can be costly. So this is where the SIOS DataKeeper can come into the picture. You can have it really overcomes the limits of the VMware mobility as well as the storage management, and it really simplifies the whole process. Essentially, what the SIOS DataKeeper solution allows you to build a failover cluster without using the shared storage. So in a virtual environment, you're going to have your virtual machines, and you're going to have additional storage attached to each virtual machine, presented just as a regular VMDK file or VHD file to that server. And the SIOS DataKeeper solution is going to keep those volumes in sync doing the block level replication between the different nodes, and it's going to integrate with failover clustering, so it still is managed very much like a failover cluster, so you don't have the limitations of the always-on availability groups. So you protect the entire instance rather than just the user-defined databases. So all your agent jobs, your logins, your passwords are replicated, and you can also support things like the distributed transactions, and all this can be done with SQL Server Standard Edition, so you don't have the same cost involved with the Enterprise Edition. So it's treated as a regular VM. The entire instance is protected, and that allows each of the infrastructure layers to use its best features without any limitations. So you can do this when you enable a SIOS DataKeeper SANless cluster. The VM admin is going to be much happier because now they can still do things like vMotion and snapshots, so they don't have to change the way they manage those VMs. They can manage them just like any other VM. At the end of the day, the people at each layer get to use the technology that they want to use without their limitations. So the DBA can use the failover clustering, so he's happy. The VM admin, he still has his VM ability and less disk to mess with the RDM, or raw device mapping, and his backup strategy doesn't change for the clustered instances. Now the SAN admin has less LUNs to manage as well, because they're just simple VMDK files. And so there's no more arguments and no more discussions among the teams. Each one is happy they get to do what they want to do for high availability, from the DBA to the SAN administrator to your virtual infrastructure. And then the business will benefit from having the best possible uptime for the critical applications that power the business, and so everyone wins. So SIOS Technology is the creator of the DataKeeper Cluster Edition. A little bit about SIOS. SIOS was founded in 1999. You might have heard of a company called Steeleye Technology. Was the original name of the company. They have headquarters in California, but really offices across the world. SIOS is focused on high availability and disaster recovery on the Windows and Linux platform, and that's really their primary focus, with 60,000 licenses installed worldwide, and you see all the partners here. So I'd like to take just a moment to give you a little product demonstration of the DataKeeper solution so you can see how it might fit into your infrastructure here. So it looks like I got disconnected while I was presenting. Let me see if I can reconnect here. My VPN is still up. Oh, that's a problem. VPN dropped. All right, it should fire right back up here. I think. There we go. All right, so as I mentioned, the SIOS DataKeeper solution, you really think of it as a storage solution for failover clustering that allows you to use local attached storage. Now, I know we've talked about a lot of running this with virtual machines, but really this runs on physical servers, virtual servers, cloud instances, exactly the same way. It allows you to build a SAN-less cluster, build a cluster without a SAN, or something called a SAN-less cluster. And I've been with the company 13 years. I've really seen kind of the demand for this shift, where when I first started, I had a lot of people looking for multi-site clusters for SQL and Exchange and other Windows workloads for disaster recovery, or customers looking to build high availability solutions without a SAN. They want to leverage local storage to save on cost or eliminate the SAN as a single point of failure. And then we start to see the shift into the virtualization environment, and that's where people deploying VMware really saw the benefit of DataKeeper to be able to still build failover clusters in VMware without giving up all the benefits of the VMware tools like the VMware HA and the vMotion and that kind of stuff. And now I see a big push into the cloud, and once again, DataKeeper is a perfect component to your cloud HA solution, because in the cloud there is no shared storage component to build a typical failover cluster instance. So you can leverage DataKeeper in the cloud as well to enable high availability and to allow you to build failover clusters. So I'm going to show you how we take a standard cluster and enable DataKeeper to build a SANless cluster. So we start with the Failover Cluster Manager, which hopefully you're familiar with. Have you ever seen? This is Microsoft Failover Clustering. I have 2 nodes in my cluster, a node called SIOS 1, a node called SIOS 2, and I have a couple roles pre-configured here. I have a SQL Server cluster, I have an SAP instance as well, and really any workload, I know we're talking SQL Server here, but any workload that you would traditionally cluster with Windows Server Failover Clustering, you can now build a SANless version of that. So this is a SQL cluster. It looks very much like your normal SQL Server shared storage cluster. The only difference, if you look closely under storage, instead of a physical disk resource, we have something called a DataKeeper volume. This is our secret sauce. This is what integrates with failover clustering to allow you to build a cluster with the local storage. So if we take a look at the properties of this, I can actually get some information about the replication rate from Failover Cluster Manager. So we see SQL right now is currently online on SIOS 2, and that's reflected here. We see that the source of this replication is SIOS 2, and the target is SIOS 1. We see some other information about the mirror. It's a synchronous mirror. It's currently in a mirroring state, all through Failover Cluster Manager. And so I would manage this just like it were a regular shared storage cluster. If I want to move this workload, I can right-click on it and move it to SIOS 1. And again, this is the benefit of doing the guest-based clustering, or clustering, inside the guest, versus just relying on VMware HA. If I need to patch the Windows, I could patch the backup server first, then fail over to it, and then patch the primary and then fail back. So my maintenance windows just went down from a few hours to just a few minutes, that in this case just a few seconds, to switch SQL from one instance to another. So now SQL is running on SIOS 1, so I could patch SIOS 2 without scheduling any downtime for that maintenance. So how do I get to this point? I'm going to show you the DataKeeper interface. This is DataKeeper. It runs as an MMC snap-in. And you can see I have the couple jobs pre-configured that are currently being used in the cluster. So I have that S drive that is replicating now from SIOS 1 to SIOS 2. And the SAP job is also in here. But I'm going to show you how to actually take the DataKeeper and create a replication of 2 independent volumes and integrate it with failover clustering. It's a very simple process, 3 steps. Where you're going to create a job, define a source, define a target, and then choose your options, and then click done, and that's all you need to do. So in this environment, I'm connected to the servers in my cluster. I see SIOS 1, SIOS 2. Each of these servers have additional volumes attached to them. You can see each volume that is not mirrored. So what I'm going to do is take the R drive, and the only requirement in terms of the storage is that the size needs to be the same on the source and target, or minimally the target needs to be as big or bigger than the source. So to take the R drive, we have a 5 gig R drive on both systems, and we're going to replicate that and integrate with the cluster. So I'm going to create a job called R drive, click create, and so here's we choose the source system. So SIOS 1 is the source. You can choose the network you want to use to carry the replication traffic, so you can specify a private subnet if you want to keep it off your public subnet. So choose that. Choose the volume you want to replicate. The R drive is the volume we said we're going to replicate. And then you choose your target system. So SIOS 2 is the target. The IP looks good. The volume looks good. And then here are the options. So we talk about this very much, but synchronous replication guarantees the data is always 100% in sync. So once again, if your recovery point objective is 0 data loss, which in many cases, for high availability, that's the objective is zero data loss. When you start talking about disaster recovery, sometimes some data loss is acceptable, but again, that's a business discussion you need to have with your stakeholders. So for servers within the same data center or in a high-speed, low-latency network, synchronous replication is going to work great, guarantee the data is always 100% in sync. If you want to replicate greater distances off-site, across a WAN or a link with higher latency, then you're going to choose asynchronous replication. And async is near real-time, so you're not losing minutes or hours of data. You're only ever potentially losing the last few writes, because the data is replicated as quickly as possible. As a write comes down on the source, it's sent to the target. However, with asynchronous, we don't wait for that write to commit on the target before we commit it on the source. So you can send those writes greater distances without any impact to your write throughput. And with asynchronous replication, you can also enable compression. So there's 9 levels of compression to save on your bandwidth consumption, and you can also specify a maximum bandwidth. So to help with your quality of service, to ensure that DataKeeper doesn't consume all the available bandwidth, you can put a cap on the bandwidth that will utilize. So that can help out as well. So for local replication, synchronous is typically the way to go. And we'll click Done. And that will create the mirror. So anything on the R drive from SIOS 1 will be written to the R drive in SIOS 2. And then we get this pop-up that asks us if we want to register this volume in the cluster. So I'm going to say yes, put that in the cluster. And so as that replication happens, I'll go over to Failover Cluster Manager, and I look in the disk, and I can see this new DataKeeper volume R. This was just created when I said yes. So put this DataKeeper volume in available storage. So if you're familiar with Failover clustering, available storage is the location where all disks that are not currently being utilized reside. So as far as failover clustering is concerned, this looks, feels, and smells just like a physical disk resource. So if I were to create a SQL Server cluster, I could run my SQL setup just like I would with a shared storage cluster, and at the point where it says select your cluster storage, it will present the DataKeeper volume R as an available storage location. Of course, I'm not going to create an entire SQL cluster here for sake of time. I'll just create an empty role. So I have this new role with no resources defined, and show you if I were to add storage to this role, it presents the DataKeeper volume as an available storage location. So I'll click yes, add that one. So I have this new role, DataKeeper volume R. It's currently online on SIOS 1. And if I look back in the DataKeeper, I see R drive is already in a mirroring state. So at this point, I really can close DataKeeper, and all the management is going to be done through Failover Cluster Manager. So once again, I can move this from one node to another. I can say move to SIOS 2, and you'll see DataKeeper will come offline and online on SIOS 2 pretty quickly. And what that process does, it controls the mirror direction. So now, instead of controlling the SCSI reservations of a typical shared storage cluster, DataKeeper controls the mirror direction. So now all the writes are going to occur on SIOS 2 and be automatically replicated back to SIOS 1 without any, without you having to go in and kick the tires or flip the mirror. It's all done through Failover Cluster Manager. So you just, if you didn't know any better, you would think this is a shared storage cluster. But under the covers, you get replication going on. So I showed you the DataKeeper interface. I showed you how we integrate failover clustering. We do have a command line interface as well that lets you do, the configuration and management if that's your thing. The one thing that is in the command line interface that is not exposed in the GUI is the ability to take a snapshot. So you can run a command called emcmd take snapshot. You pass the volume letters of the volumes you want to take a snapshot of, and this is run on your target system. So, one of the things that always on availability groups does well that you can't do with a failover cluster is something called a readable secondary. So you're not going to be able to read the data on the target system in a normal fashion. There's no real-time readable secondary here. But what you can do is run this command to take a snapshot, and that will take a point-in-time application-consistent snapshot. So it's integrated with VSS, so your databases will be in an application-consistent state on the snapshot. And at that point, you could mount those databases from another instance of SQL Server to run your month-end reports, or take a backup of that data for to supplement your other backup schemes, copy it off to some archive storage, so you have multiple copies of your data. Especially if you're doing replicating across a WAN, it's a great way to supplement your backup scheme, so you have point-in-time copies of your databases stored in off-site location. So what real-time replication does not replace is a backup. So even though you are replicating data in real time and you have it in, this shows a 2-node cluster, but you could actually replicate to multiple targets and have a 3-node, maybe 2 nodes locally, 1 node remotely. So you have a combination of high availability and disaster recovery. But if someone drops a table on node A, well, that table is going to be dropped on node B and node C, or someone, corrupts the data in some way, shape, or form. That's going to be, replicated real time to all the nodes. So you still need to have the ability to restore from a backup in those cases. So the real-time replication does not replace the need to do a backup, but it enables the high availability configurations that that we're talking about. So I'm going to take the rest of the hour here and open up the meeting for some questions. So I think there's a Q&A tab in the interface. If you haven't already submitted questions, I'm going to ask Greg to join us again and feed me some of the questions. So take some time now and ask your questions, and I'll stay as long as we need to until the top of the hour to address your questions.
All right, great, thanks, Dave. Just one question. Is there any URLs or anything that you can share while we're doing the Q&A with people can find out more about DataKeeper?
Yeah, absolutely. I'll pull up the last screen of my presentation. It has some information, and let's see here. So here's a great URL. Well, of course, the website, us.sios.com. You get there, and you're going to find pretty much everything you need. There's also, you can get trial copies of DataKeeper if you want to try it. So it's probably easy. You pick up the phone and give us a call if you have questions. We can send you out some white papers. I think, Greg, you have a final poll question. Just let us know if you want us to contact you. Answer this question that Greg's going to put up in a moment here, and we'll definitely have someone reach out to you and get you some information.
Okay, great. All right, the first question that came in, and again, we have a bunch of questions coming in at this point, but the first question that came in is related to, do you have any recommendations on how to handle when you have, as a DBA, how to work with different teams when everybody's pointing the finger that it's, it's not our fault, it's not our problems, and not the network, it's not the storage?
Yeah, that's a that is a tough question. So how do you get everyone in the same room and stop the yelling and screaming? Like I said, you really have to get the business stakeholders involved as well. I mean, everyone needs to understand and be on the same page as to what the business really requires, and people just need to be honest about that, and they need to be able to listen to the DBA's concerns that VMware HA is a great solution in many circumstances, but in some circumstances, if your recovery time objective is less than a few minutes, then VMware HA is not going to be the solution. Or if you signed up for SLAs, 5 nines of SLAs, VMware HA alone is not going to be your solution. So, having the open and frank discussions without it getting heated is difficult. But then, the other side of the coin is, the troubleshooting the issues when they do occur. That can be a challenge, and it's hard to really point the finger. For the DBA, you may not have the view into the virtual infrastructure or in down to the SAN level. And there are other tools. There's another tool from SIOS Technology called SIOS IQ, which can help facilitate that. So if you want more information on that, it's basically machine-based learning analytics for your virtual infrastructure, where you can have from a dashboard, you can get some really deep root cause analysis. So if you're having an issue, this will really kind of bubble up where in that stack that issue is being being presented, whether it's storage or network or compute or application. So that's something that you might want to check out, the SIOS IQ solution for VMware environment specifically.
Okay. All right, the next question is related to how does the failover actually happen? Can you kind of just talk through that a little bit with I guess, with using DataKeeper on top of the cluster?
Sure. So it really is exactly the same as a traditional shared storage cluster. If you're not familiar with traditional shared storage clusters, there are a few things that can cause a failover to initiate. And even before a failover occurs, sometimes it could be recovered locally on that local system. So anything from a whole system failure, where the entire server just goes dark, like you pulled the power cord or something along those lines, that will cause the remaining servers to say, hey, we no longer can talk to the primary node, and so we're going to recover that application. So it goes in and initiates the recovery process. So as you saw in the demonstration, a typical cluster consists of many cluster resources. Typically, a storage resource is one of the first things to come online. And so in a shared storage cluster, that would mean that the SCSI reservation would be given to the new node coming online. In the DataKeeper solution, it means that the DataKeeper solution will unlock that volume and make it the source. And then you have the SQL Server services will start up. You also recover a name and an IP address. So one of the great things about failover clustering in comparison to the database mirroring or even the always-on availability groups is that it actually creates a cluster computer object that represents the SQL Server instance itself. And so when it moves from one node to another, there really is, as far as the application is concerned, there's no change at all. It's still, the application thinks it's still connected to the same instance, even though it's moving between the different nodes. And that's facilitated through the cluster computer object that is created when you create the SQL Server cluster. So that will move between the different nodes. So that has to be recovered on a node as well. So, as you saw in the failover cluster demo, a planned switchover can take, 20 to 30 seconds. A lot has to do with, how long it takes SQL Server to start up on the other end. So that depends on what's going on with SQL Server at that point in time. Same thing would happen if I pulled the power cord on that server. It would be an approximate time frame, in that under that minute type failover. Again, with the SQL Server startup taking the lion's share of that. When SQL starts from an unexpected failure, just like in a standalone SQL instance, if you pull the power cord and then you turn the server back on, when SQL Server starts, it has to look at the log files and the data files and see where they were, if there was any uncommitted transactions that need to be rolled back. SQL Server will have to do a soft recovery, and you'll see that in the log files in any unexpected failure. SQL Server is doing a soft recovery, bringing these databases online. So that that's all part of the recovery process.
Okay, the next question, Dave, somebody just said basically their VM administrators saying there's no need to cluster the VMs for SQL. So just wondering, could you provide any talking points to why it is important to cluster, even if you're running on a VMware?
Well, I think the two biggest points to make are you need to define your recovery time objective, and that's not something that you just pull out of thin air, right? It's not something that the VM administrator is going to pull out of thin air. That's something that the business owner is going to tell you. Is going to say, well, how long can you stand to be offline? And if that recovery time objective, again, is less than that 2 to 3 minutes, then you just have to say, well, look, let's do a test. Maybe not on a production server, but let's pull the power cord on this physical host, and let's see how long it takes for SQL to recover in two circumstances. One, where we're just using VMware HA alone, and then we'll do another test, and we have a failover cluster configured with one node running on one host and one node running on another host. And that brings up a point I didn't even cover. And if you're doing clustering between servers, you got to make sure that those the virtual machines are running on different physical hosts, because you're not going to have any sort of HA if you lose a host that's hosting both of those virtual machines. So you're going to use some anti-infinity rules there. But back to your point, so you show the recovery time objective is much shorter with a clustered instance of SQL Server. And then you ask the question, well, what about when I need to apply Windows patches? Can I schedule downtime, during the business day, after hours, on weekends? What is your tolerance for downtime? And that comes down to your service level agreements. Like how much does this need to be up online? As I said, some applications are critical from 8 to 5, 8 to 6 each day, but after hours, no one cares. Do what you need to do, take it offline. But if it's a 24/7, back end for your web, your public-facing website, taking orders, anything like that, then that is going to be much more stringent. And so, if you can say, hey, with VMware HA, every month or however often I want to patch my server, what you don't want to let them go unpatched for too long when you're talking about some critical security update. We're going to need to schedule downtime. We need an hour. We need 2 hours. And then you got to talk to your administrator. Say, oh, sorry guys, I know you wanted to take off this weekend and enjoy time with your family, but we have a service window, and the only time we can do it is 2 a.m. on Saturday, Sunday morning. That's not always the best option for your team as well. So, those are the two main things. If planned maintenance is really something you want to try to minimize the downtime with, or if your recovery time objective is greater than you're less than 2 minutes, then VMware HA is really the only option, and you just need to be able to articulate that to all the stakeholders. And again, sometimes you have to go over the heads of the, you can't just be talking to the VM admins. Sometimes you just got to get the stakeholders involved in the conversation so they can make the logical decision.
Okay. All right. Another question here is just somebody just says they're hesitant about moving SQL Server to a VM environment. They're just not sure if they're going to get all the actual data that's things that are occurring in the background from their VM admins, storage admins. So just wondering, are there tools that come with VMware? Are there ways that they can see kind of what's happening to kind of feel more comfortable with moving to VM?
Yeah, I mean, that's always the, you give up that sort of autonomy when you from a physical server, you spec out the server that you need. You spec out, how much RAM, your CPU configurations, and storage. Still, sometimes you have to fight with the SAN admin unless you bought some local attached storage. So when you go to a virtual environment, you give up all that because now you're sharing those resources with other clients and that other VMs running on that server. And the storage is the same thing. You're sharing that storage with other, other environments. I'm not overly, familiar with the tools provided by VMware to look at that. But again, going back to that SIOS IQ solution, that can really give you a great insight into what's going on that around you that might impact you. You might have something that is happening in an entirely different VM that's not even part of your, domain, that is causing a lot of disk thrashing or consuming a whole bunch of resources on the same host that your server is running on. So, well, you may not be down. All of a sudden, you're getting phone calls from users like, oh, why is this query taking so long to complete, so sluggish today? And you're looking at it like, I don't know. I mean, I didn't change anything. The VM looks fine to me. The SIOS IQ solution through the dashboard will pinpoint that. Through its machine learning, it will know that this is not normal behavior, and it will show you those resources that are consuming those processes, which could be impacting your the performance of your virtual machine. So moving to virtual environments is not always done for the reasons of, hey, this is going to be much better than running on a physical server, but it's usually more of a cost savings, consolidation type move, and you sometimes go along reluctantly. Fortunately, done right, there's very little difference between running physical and virtual environments if you have control and you have people cooperating with you to ensure that you have the resources needed in that environment.
All right. Okay. All right. Another question here. Somebody just said it seems like the trend now is that people are moving more and more SQL servers to VM environments, and they're just wondering, do you have any information about that? Is that the trend, and is that sort of the future of running SQL Server?
Yeah, I mean, I would say it's more than the trend now. I would say it's the default, in my experience. And the customers that are coming and talking to me, the number of customers that are running on physical servers versus either cloud instances or virtual environments, we're talking, if I had to put a percentage on it, it's definitely a single percent. It's probably, closer to 5% or less of any of the customers that I'm talking to today that are running SQL Server. The physical servers are just really, not very prevalent out there as well. So I'd say yes, it's a trend, and then really that's been a trend for 5 years. Now the trend is cloud. People are looking at, okay, I have this workload, and now we need to run it in the cloud. And the cloud gives you so many options, right? So you can take what you run on-prem today and just lift and shift into the cloud using infrastructure as a service. So you can move your failover clusters into the cloud with DataKeeper, or you can implement the always-on availability groups if that's what you're using today. Or you can re-architect entirely, right? So there's platform as a service. You can, say, well, man, I don't need to run my own SQL Server. I'm going to use SQL Pass, or one of the options available from the cloud provider. So there's lots of really interesting options when you look at the cloud, and that's really, I see the trend now. I mean, virtual is kind of the default standard. Cloud is more the trend that I'm seeing.
Great. All right. Well, we're actually out of time, so I'm going to wrap things up. So thanks, Dave, for sharing all that awesome information. And also want to thank SIOS for sponsoring today's webcast. As Dave mentioned, here's some links to check out more information about SIOS products. So take a look at DataKeeper and SIOS IQ that David mentioned today. The webcast was recorded, and you will receive a follow-up email with links to view the archive. And I'll get a copy of the slides from Dave as well, and we'll get those posted with the archive. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.